Powers and exponents! Powers! A power is the result of repeated multiplication of the same factor. We're going to focus on repeated multiplication. Examples! We have 81 is equal to 3 times 3 times 3 times 3. So all the multiplications of individual 3's represent our individual factors. A power can be written in the form that has two parts. Part 1, a number called the base, and a number called the exponent. So we can rewrite 81 as 3 times 3 times 3 times 3, or it will have a base of 3 and the exponent of 4. We can state this as 3 to the power of 4. Let's get a formal definition for base. The base is used as a factor. For example, if we have 3 to the power of 4, the base would be 3. If we have parentheses negative 3, close parentheses to the power of 5, the negative 3 would be the base. Here we have to watch out for a common error. In this problem, the base is negative 3. Check. The common error is to think that the base is 3. Boop, 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 boop. In the following situation, we have parentheses 1.5 close parentheses to the power of 4. Our base is 1.5. In the last situation, we have variables. So we have b to the power of x. Our base here is b. And these are some quick examples of different bases. Exponents! Definition. The exponents show the number of repeated multiplication. For example, let's look at 3 to the power of 4 again. Our power, or the superscript 4 here, represent the exponents. In our second example, with negative 3 quantity to the 5th power, well, the 5, the superscript 5, represents our exponents. Similarly, our 4 in our next example is our exponents. And in our variable example, we have b to the power of x. X is our exponents. And that's some examples of exponents. Evaluate the power. In example A, we have 3 to the power of 2. The base value of 3, and because of our exponent is 2, this is telling us we need to multiply 2 copies of 3. In the end, we're going to get 3 times 3, which gives us 9. And for another example, evaluating powers. Example B. Now we have the quantity of negative 3 to the 3rd power. In this situation, our exponent is 3. So this will tell us that we're going to have 3 sets of things that are exactly the same that are going to be multiplied together. Our base value is negative 3. So in each one of these parentheses, we should fill in negative 3. We first have negative 3 times negative 3, giving us positive 9. Then we'll continue bringing down the last negative 3 for us to multiply. In the end, we have 9 times negative 3, which give us negative 27. Let's go over our 2 examples that we just went over. In example A, we have 3 to the power of 2, which gives us 9. And in example B, we had the quantity of negative 3 to the power of 3, or the quantity of negative 3 cubed is equal to negative 27. What we want to do now is look at one of the most common errors involving powers and exponents. On the left, we have negative 4 to the power of 2. This does not equal to what's on the right, where we have the quantity of negative 4 to the power of 2. Let's figure out why they are different. So on the left, what this really says is that we have negative 1 times 4 times 4. The reason for this is because the exponent 2 only directly affects the number right next to it. In this case, it is the quantity of 4. Since there are no parentheses to indicate that this 4 is negative, it itself is a multiple on the outside. So on the left, we're going to end up with negative 16. Let's check out what's happening on the right. We do have a quantity squared, 2 sets of statements that are exactly the same that are multiplied together. However, on the inside, we have a negative 4 because of the parentheses. So we have negative 4 times negative 4. This would give us positive 16. One of the most common errors. On the left side, we will accidentally indicate the negative symbol is a part of the 4 squared. This can only happen if we forcefully add parentheses. And that's the basics of exponents. Just watch out for this common error. Like and subscribe. And subscribe back next time for more problems.